I just heard about this great place called the Challenger Learning Center. What is the Challenger Learning Center?
The Challenger Learning Center is named for the Challenger space shuttle, specifically the mission STS-51L and crew of 7. Commander Francis Dick Scobie, pilot Michael Smith, mission specialists Ronald McNair, Ellison Onizuka, and Judith Resnick, and civilian payload specialists Gregory Jarvis and Krista McCullough. After months of training, the morning of January 28, 1986 arrived, and after many delays, the crew and NASA were full of anticipation. As everyone watched the Challenger lift off, the unthinkable happened. 73 seconds into liftoff, the Challenger shuttle exploded, leading to the death of all 7 astronauts on board. Within 1 hour, 85% of America knew of the tragedy. The families of the fallen astronauts wanted to create a memorial for them, but they didn't just want a statue or memorial in a fixed location. They wanted a living memorial that would continue their mission to educate the world in STEM.
Ago.
Well, I remember my 4-year-old daughter and my 3-year-old son, and I was pregnant with my 3rd child, and so I was home, and we were on the couch all cuddled up watching and waiting for this amazing event. And when it went up and exploded, I had to explain to the kids, oh my gosh, they asked me, Mom, what just happened? And I had to say it exploded. And so it gave us an opportunity to talk about the cost that people's lives are at stake when people go out and do things like this. So it was sad, but at the same time, it gave us an opportunity to discuss the cost. And I think that's important to realize, that things do cost, that people's lives are shed sometimes when you're doing something like this.
Okay.
Wow, that sounds neat. What will my students do?
A Challenger mission is a 2.5-hour-long simulated space mission. Your students are going to spend half of their time in mission control, acting as mission controllers, keeping the astronauts safe. And in the second half of the mission, they will be astronauts on a spacecraft running scientific tests.
How do you usually see students change and grow from the beginning of a mission to the end of a mission? Like, what will they get out of it? What are they going to learn? How will I be able to see that when we get back to our classroom?
At the beginning of a mission, we often find the students are super hesitant and sort of nervous. And then as the mission starts to progress, they get so wrapped up in what they're doing that sirens are going off and they're just like, don't bother me, I want to do my work.
What kind of technology will they be using?
So, the Challenger Learning Center here at Sacramento, in October, this will be our 16th year serving students in the Sacramento area. And sometimes people ask, how does this whole simulator work? Well, we have about 20 Mac Mini computers that are running software that was developed by the Challenger Learning Center for Space Science Education and with some input from NASA.
Each mission is led by trained mission commanders.
We want to build the probe, we want to send it to the comet, and then the most important part is we have to get information back from that probe so we can learn about that comet. Now, in order for us to succeed, we're all going to have to work together as a team. As a matter of fact, teamwork is the most important part of today's mission. As long as we work together, we will succeed. On 3, teamwork. Make it loud. Here we go. 1, 2, 3. Teamwork! That's more like it. So in a moment, we're going to have liftoff. When you hear us lift off, I want you to raise your hands like you're a superhero. There it is. All right, if you can imagine it, we are starting to fly through Earth's atmosphere. And
During each mission, each participant is assigned a very particular role, whether that be on the communication team, the data team, the navigation team, the medical team, the probe team, the remote team, the life support team, or the isolation team.
Space weather. Go. Space weather's go. Data. Go. Space control, this is
Go.
the space station. We are beginning our tasks. Over.
Space station, this is mission control. We acknowledge. Over.
The communication team is responsible for all of the communications between the spacecraft and mission control.
Mission control, this is space station. Acknowledge. Over.
The navigation team is responsible for navigating the spacecraft. In most of the scenarios, all of the work is done in the spacecraft, while all the instructions will be in mission control. So, the team is required to work long distance overhead.
Isolation team is check chemical
The isolation team is the hazmat team, meaning they're working with all of the hazardous materials. Those hazardous materials are behind glass in an isolation chamber. To manipulate them, the team is given robotic arms. The remote team is performing hands-on experiments, whether they're botanists or geologists on board the spacecraft. They work with their hands inside gloves in a box that we call a glove box. This is so that they do not contaminate the samples.
Silver cover to the left to expose the black probe motherboard.
The probe team is responsible for building the probe motherboard or the equipment module motherboard. Now once again, they work long distance over headsets because all the parts are in the spacecraft and all the instructions are in mission control. The medical team is responsible for testing the health of all of the astronauts. They run various tests such as auditory and visual reaction time, blood pressure, skin temperature, and pulse. This lets them know how the human body reacts to living in space.
Remote team, are you ready to receive a message?
The life support team is responsible for making sure all the systems on board the spacecraft are working properly. They will look at various things such as hygrometer, their oxygen system, they'll be doing pH tests, as well as TDS. The data team, they're the message managers. They receive all the messages their teammates send and determine whether to forward those to the opposite room or to print them out.
So basically that means two things. Number one, don't panic. Number two, life support. Your teammates are going to tell you what to do. So for right now, all you can do is continue to do your job. But as soon as you know how to solve the emergency, you're in charge of making sure.
Each mission may include emergencies that the astronauts and mission controls have to solve in order to save the astronauts.
Wiggle around on our chairs. We're generating a static. Who has to touch these black metal bars? Every astronaut. Now you can define astronaut as anybody in space. Is every astronaut touching the black metal bar? I'm not, right? Is there anyone else? Oh, 3 beeps, usually good news. And you have solved the hygrometer.
Each mission also includes celebration for all of the successes that happen.
Let's give navigation a big round of
Halfway through the mission, all participants are brought into mission control where they hold a mid-briefing. That's where they tell each other a little bit about what they were doing in the first half, and that's to prepare for the next step, which is to actually switch places.
Please join us in the countdown.
set. 10, 9,
8, 7, 6, 5, 4, 3, 2, 1. Launch that probe!
probe launch is in progress. Keep an eye on that probe. Here's hoping it spins. Woo! Give probes a big round of applause. Now that probe should be heading towards the tail of a comet. So if you see that white streak in the sky, we're going to clap for navigation. Here's hoping that. There it is. Good job, navigation. Information about our comet. Remember, because we're supposed to talk. Probe, did you build up any backup systems? Did you put any spare parts in that probe?
No, the mission control didn't give us any directions.
No directions? Okay, so maybe it'll fix itself. We lucked out. Alright, so every comet has 3 main parts. The center of a comet is called the nucleus, and it's basically a frozen solid ball. You can think of it as like a dirty snowball. Okay? The coma is a gas cloud that surrounds the nucleus, and the tail is dust or gas that trails behind the comet. Now, if I told you you had to get into the comet and get information back, yeah, do you think maybe you had a successful mission?
Yeah.
So listen, go to the very last special message, the last one in the book. Let your teammates know that the mission was successful.
Mission control, this is Space Station. I have a message for the entire crew. Our mission has been successful. We will see you back on Earth. Over.
We have to wait for them to agree.
Space Station, this is Mission Control. We acknowledge. Congratulations on a job well done. Mission Control out.
Math skills. I want to remind you, knowing what a number is math. Did you record and analyze data? Did you write something down and think about it? Okay. Did you run some scientific tests? Did you communicate with others? Did you use technology? Here's a tough one. Did you have fun? Now, if you had a lot of fun, feel free to raise 2 hands. And if you just had a massive amount of fun, feel free to shake those hands. Good. Put those hands down. Did you realize you just said you had a massive amount of fun doing schoolwork? Oh. Now, I will admit, this is definitely not what a classroom looks like. But if you think about it, yeah, you were using everything you're learning in school to be successful today. So what we just did was we gave you a real-world application for what you're learning in school. So Ms. Rogers gives you homework and she's giving you tests and things to learn. She's actually doing you a favor. She's preparing you to be successful doing anything you want in life because she's giving you the skills you need. Here we go on 3. Mission accomplished. 1, 2, 3.
Mission accomplished!
Stay there.
Take it to the bus, eating it in wrappers, or knocking on the bus with the wrappers.
This mission was really, really fun. Yeah. So we got to work with the glove box, which was fun because we got to put our hands in, and it was very tight, and we used robotic arms, and it's just fun, and I'm looking forward to it. Very fun. It's also interesting, and we get to do a lot of experiments.
Most often, teachers thank us at the end of a mission. Thank you so much. This was an excellent field trip. And thank you for showing us the potential that our students have. Very often, when you're in the classroom, you don't get to really observe your students the way you can during a mission and see them excel.
Well, I was trying to calculate back, but we actually were the class of its first inception. So the very first Challenger mission here at the Discovery Museum involved our classes at Our classes enjoy coming back each year, as do the teachers, because it not only involves the curriculum of science, but it engages our students in all areas: communication, all other academics. They do their math, their English language arts. We're also, of course, sharing with each other in terms of being able to do the debriefing, so they have to verbally then explain. Probe team, for example, has to give the directions on how to build the probe, so there are a lot of opportunities for the children to communicate with each other. And we do our own debriefing, so there's a lot of English language arts when we return back to Leggett, and we kind of synthesize everything that's gone on for the day's events.
It's excellent because the kids get to come and have a hands-on experience. They get to experience how to use math and science and reading, and they get to see that all their schooling is purposeful. There is a purpose at the end of the rainbow here. So I think it's an excellent field trip.
What if I want to bring my family and not just my students? Do you have opportunities for my family to go?
We often have people ask the question, how do I do this if I don't have a school group? And we have community missions. There are some Friday nights where we open up the Challenger Learning Center to the general public. I just have 2 rules. You have to be at least 9 years old, and you cannot be older than 109.
How can I sign up?
To sign up for a mission, the teachers would just call the museum's reservation line and talk to our scheduler, Janae. You just want to let her know that you're interested in doing a Challenger mission, what date that you're interested in, and what time. Do you want to come in at 9 o'clock in the morning or 12:15 in the afternoon?
How much will it cost?
So for a school group, the cost is $500 for a mission. And then if you want to do a community mission, if you're not a member of the museum, it's $20 a person. If you do happen to be members, it's $15 a person. If you have a large number of people in your group and you're thinking, hey, how do I get that better price? Just pay $60 for a membership and you can get that discount.
I think this sounds like not just good for students, but a great training opportunity for my colleagues, other teachers that I work with. Do you have opportunities for teachers to learn as well as students?
Sometimes groups of people want to have their own private mission. That's cool. We just ask that you bring me 20 people paying $20 a piece, and you can set up a mission for after school if you'd like, or even after hours. We often do missions from 4 to 6 p.m. or 6 to 8:30.